Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Data Science and Business Intelligence meeting. This is the first meeting of the year, and to give you a quick idea, we like to meet roughly 10 times a year talking about topics in the data science and business intelligence space. So that's R, Python, Power BI, reporting services, analysis services, basically anything that is fairly interesting for people working in analytics. With this, I'm going to hand it over to our first speaker of the year for this group, and that is Paul Turley. Please take it away.
Thank you, Kevin. I appreciate it. Let's see. I'm going to share my screen. It's a new platform for me. Appreciate the invitation, first of all. It's a pleasure to be presenting to a new user group that haven't had a chance to work with you folks before. I'll introduce myself and talk a little bit about what I do and my involvement in the community. My name is Paul Turley. I'm a principal consultant with 3Cloud Solutions, member of the Microsoft MVP program now for 11 years. Originally from Vancouver, Washington, and heavily involved in the Oregon SQL community. So past chapter there, and now an independent user group. But I'll save the secret for last. So we're going to talk about doing Power BI the right way from the perspective of database developers, and talk about the different perspective and different disciplines of traditional database development, IT-based data management, and BI and self-service analytics, and how those worlds can not only collide, but how those worlds can come together to be very complementary. So, what's this all about? I have been working with Power BI since before it was Power BI, and the tools that kind of led up to the advent of Power BI, a la SQL Server, integration services, analysis services, reporting services, all of those great technologies that came together under the umbrella of Power BI as it kind of graduated through Power Pivot and Excel and analysis services, Tabular. And in doing so, Microsoft really kind of shifted their focus from being very, very focused on the IT community, supporting developers and DBAs and those of us who come from those disciplines, to self-service analytics. And the industry has shifted. Microsoft, I think, have kind of shifted as an industry, but that really kind of puts people in two different camps in the way that they think about managing data. And my goal is to bring those camps together and get those people talking to each other, and to take the best of the different philosophies and different approaches to the way that we curate, we analyze, govern, and learn from our business data. So a little bit about me very quickly. I started out in the TV news business way back in the day. That's what I went to college to learn. Had a short-lived, promising career in the TV news. Worked for a couple of TV stations. Loved to push buttons and make pictures. That's what really kind of brought me to that. But I actually had a mishap. I broke my foot, and I ended up having to work at a desk job. And a good friend who I was working with at the time got me into doing help desk support for a small healthcare software startup. And that got me into IT and eventually working with data and software. And eventually I kind of fell in love with doing IT training and consulting and, making computers do very interesting things. And in 2003, I discovered business intelligence and analytics. And with some experience with tools like SQL Server and Access and Visual Basic, kind of grew up in that space. I learned to love data reporting and BI, and had the opportunity to participate as a co-author on a couple of books, and really enjoyed doing that. And so I became the co-author and then lead author and then the solo author of a number of different titles from Wrox Press. And so I spent a lot of my nights and weekends writing tech books and supporting my IT habit. And I was recognized as a Microsoft MVP in 2009. Worked for a couple different training and consulting companies, had my own company for a while, and I went to work for a great company called Pragmatic Works. Pragmatic Works was acquired a few years ago by a company called 3Cloud Solutions. That's the company that I work for today. We're in the Azure space across the entire spectrum. We do consulting, some training and mentoring on anything that has to do with Azure. And I work within the data and analytics group, and specifically lead the Power BI analytics community, where we focus on analyzing and curating data. So my wife and I decided to do something crazy after the kids left home, and that is that we went on the road. So last year, early spring, we sold the house. We purchased a Class A motorhome, and we headed east. So from Vancouver, Washington, we headed across the country to Florida. I spoke at a conference, had a chance to sit down and meet with a number of folks in the community. And I've been blogging about that over the past few months at dataontheroad.blog. And see, when I applied a new theme here, it wrapped the text. So dataontheroad.blog is my blog. And so I sit down with community leaders and folks who I've worked with over the years in the community, and we talk about community. We talk about this thriving data community that we have in the Microsoft space. My tech blog, which I've been posting to since about 2008, 2009, SQL Server BI.blog, and I'll refer to some content that I have up on my blog to support this presentation. So you're welcome to follow me. The kind of the short version of a long story is that we were in Florida, and my daughter needed some medical support. So we a couple months ago we turned west and we headed to California, which is where we are now. I'm actually on the central coast of California. If you listen very carefully, you can hear the waves beating on the beach just outside of our motorhome here in Grover Beach, California, which is where we are right now. I work full time out of the bus. I'm well connected, get a lot of tech in the bus, and I work full time supporting customers managing and architecting BI solutions. Okay, what are we going to talk about? So we're going to talk about managing Power BI projects and managing them in a way that they can be future proof. We'll talk about kind of the best of breed lessons learned from self-service analytics, and also from IT-driven analytics and business intelligence and data management, and talk about how those worlds can come together. So we'll talk about managing project files, versioning, team collaboration, talk about the way that we access data sources, and then some discipline around things like object naming, designing models. We'll talk a little bit about security, and then how to manage deployments and updates. And I'm going to share with you some of the techniques and the practices that I use in my Power BI projects that have been successful for me. And I'm not going to tell you that I have all of the right answers, but I'm going to tell you that they are tried and tested. And there are a lot of folks that I work with in the industry who I've learned from and collaborated with. And there are other folks in the industry who might use Power BI a little bit differently. So I'm not going to claim to have all of the answers, but I think I've got a good pattern with a proven track record. So when we think about Power BI as a tool, if you were to ask 10 people to describe what you do with Power BI and how a business user or any user for that fact uses Power BI, you'd probably get about 5 different answers, because it's a very, very broad tool with a lot of capabilities that can be used to support a lot of different use cases. But these are very common use cases. Power BI is used for ad hoc analysis. An individual sits down, fires up desktop, imports some text files, scrapes a website, imports some data from Excel, might hit a SQL Server database, might hit data that's stored in the cloud somewhere, maybe in a data lake, and then ad hoc they mash that data up and they analyze it. Quick and dirty, maybe they publish it and share it with a few folks. But that's what we do. Quick reporting. It's something that you can use to get answers very, very quickly. You transform, you shape the data as you go. The model evolves over time. We drag and drop to create charts and graphs and cards. And if something doesn't work, you just change it. See how it works in a table. If that doesn't answer the question, you try it in a column chart or in a line chart. And these things just evolve over time. But in doing that, we typically don't pay attention to things like standard naming conventions, adhering strictly to the discipline of modeling and relationships. Clean data, we'll clean it up as we go. Documentation, people ought to be able to figure it out when they use our reports. And version control, what's that? Who cares? So this is the typical use case when you think about modern self-service BI tools, a la Tableau and Click and any number of other tools that I think Power BI has kind of evolved to compete with. This is what we typically think of, which means that folks working within the disciplined environment of IT shops often see Power BI as kind of this rogue loose cannon tool that's used to work around discipline and work around process. All right, well, let's flip the coin a little bit and talk about how database developers and database administrators typically see the world of data. Data quality is enforced in the database. The database, particularly our data warehouse, is a single version of the truth, and it needs to be accurate, needs to be governed, there needs to be discipline around it. We want to avoid making copies of data. We want to avoid data silos. In other words, we don't want people copying data down into Excel and managing spreadsheets on their desktops. All of our requirements are documented. Everything is traceable. We have version control. We implement DevOps or development operations, meaning that we develop in a development environment to requirements. We then deploy to a development sandbox, do some unit testing, pass that over to QA. They do some testing. We have rigor around those processes, and eventually we ship to prod. And we do so adhering to very specific data governance rules. DBAs typically want to script and automate everything, make sure that we have repeatable processes, and we are very, very strict about things like naming conventions, implementing standards like Pascal case and camel case, and back in the day, things like Hungarian notation. And so there's a lot of rigor around things like that. We spend most of our time making sure that we enforce the rules rather than trying to work around them. All right. So as we step back and think about, well, which of these two approaches is right for our needs? One size doesn't always fit all. And so with some planning, informal projects can be adapted and can evolve to meet enterprise needs, but that's not something that happens naturally. You need to know when you keep and update a design, and you need to also know when it's appropriate to learn from maybe a self-service BI project or some quick ad hoc analysis. Learn from that, toss it, start over, do it right. Maybe the third time, not the second time, but it's an iterative and sometimes an evolutionary process. And a lot of that really depends on the volume of data. It depends on the number of users who are going to consume it. It depends on how long that solution needs to be around and how long we need to support it. If the CEO needs answers today, maybe that's an ad hoc project. And if, the enterprise, the, managers within the organization, they need something that's going to be around that we can support and maintain, that's a completely different proposition. All right, so how do you plan for scale? Well, I'm going to work through this slide very quickly just to show you all the animations. So the Power BI platform enables us to use Power BI in an ad hoc fashion that's very approachable, easy to adopt, and pretty inexpensive if we're not supporting a lot of enterprise users. Power BI Pro license will let you manage up to 1 gigabyte of compressed data in an imported data model. Get other options as well. But it's inexpensive. It's $10 per user per month. Premium per user is kind of the next step in the continuum. Will let you manage up to 100 gigabytes of compressed data in an import model at a cost of about $20 per user per month. Now, I try to stay away from quoting licensing costs because, Microsoft have discounts for, education and healthcare and a lot of different ways that prices change. But really all the good stuff and a lot of the things that I'm going to show you are available in premium capacity, either premium per user or where your tenant capacity is managed under premium. And in that environment, you don't have to license every user individually. We can create data models, build all of our measures, create that single version of the truth, build reports that use those curated and tested data models, and publish those as a workspace app. And then any user within our organization would be able to access and use those reports under premium capacity licensing. Now, it's not cheap to get started at a cost of about $5,000 per month. If that's not approachable, if you don't have a number of users to justify that cost, premium per user might be a better choice. And if you're a very small shop and you're working in a more ad hoc fashion, then you can go back to pro licensing. So I'm just going to leave this for reference and move forward. I will pause right here. Let me just ask a couple of questions and see if we can kind of get people chatting a bit. How many, and Kevin, I'm not quite sure how to get feedback from the groups. I'm not as familiar with the platform and I don't have access to the chat window. So I guess I'll just ask you to relay answers to questions. But how many of you work in an environment where you have access to either premium per user or premium capacity licensing?
So folks, put those answers in chat, and I will note that there's usually about a 10 to 20 second delay with Twitch. So I'm going to vamp for maybe 10 to 20 seconds to give people an opportunity. We've got one person who does. I will say personally, I don't. We use Power BI report server, but have not gone to the premium capacity. So we do have some people in chat who do have access to premium. Probably not a majority, is my guess.
Okay, good. That's good feedback. And of course, the other side of the question is who of you are using Power BI in a less formal, more ad hoc fashion, maybe more as business users or to managing your own small projects that are less formal.
We'll see. So, folks, who is less formal Power BI user? Maybe you're just using desktop. Maybe you're just using it as a business analysis tool.
I'm going to keep moving, and we'll check back now that I'm putting some questions out there. But I'm going to move forward so that we can kind of keep our cadence up. So, big question: is Power BI enterprise ready? As Power BI evolved as a product, and I would say it's a pretty mature product today in terms of its ability to consume data and the ability to visualize and analyze data. I think the DevOps and the pure IT story around Power BI continues to evolve, as you'll see, and I'll be talking about that a bit. But it raises this big question. Since Power BI is really known to be an ad hoc self-service tool, is it really an enterprise-ready tool as well? And to that, I would say, we can manage large-scale data. How big? As big as you want. And typically, we have to think about, do we import data into a data model where it sits in memory in compressed form? Or do we utilize the direct query capability of Power BI? And there are trade-offs when you use direct query. But if you are using, Databricks with Delta Lake or Azure Synapse Analytics or Snowflake, any number of very large scale, scaled out data warehouse solutions, we can use Power BI over that data. And the sky's the limit in terms of volume. We're talking terabytes and petabytes. And we can create hybrid and composite models that give us the best of both worlds, both very high performance with imported and compressed data, as well as direct query as we drill down into details or do aggregation over very, very large volumes of data. So we have an answer for pretty much any problem when it comes to data volume, but the solutions get a little more complicated when we start getting into that realm. Broad user support. How many users can we support? Well, premium capacity gives you the ability from a licensing perspective to support anybody in your organization. And if you work for a very large organization, that might be thousands or tens of thousands of users. I just bumped my camera there. The cloud is all about scale, and of course with scale comes some cost associated with that. So just opening the door for premium capacity is not the end of the road. There are different levels of premium capacity SKUs that would give you more capacity, more throughput, and better performance as well. Team development collaboration, we're going to talk about this specifically. We've got some good news there, some great features, and also a lot of evolving capabilities as we move forward. Data governance, well, Power BI is not a governance tool, but we can certainly adhere to data governance policies. We can use Power BI in projects and solutions where we have a master data management solution, a data catalog, and we can certify data sets as being promoted, endorsed, and certified, meaning that they have adhered to our internal organization governance policies, and we know that this is a trustworthy set of data. Data management policies, lifecycle and deployment, versioning. Again, it's a tough thing with a BI tool with Power BI, but the story keeps getting better and better and better. Can we embed Power BI reports into custom applications? Absolutely. There are a number of ISVs who offer a pay-for service on their platform, doing whatever they do in the industry. Managing medical data or managing real estate or pretty much any industry you can imagine, and the reporting is offered through Power BI because they are embedding Power BI visuals, reports, and dashboards into their solutions. Great story, very, very mature capability. Can it be automated? You bet. With PowerShell, with whatever your favorite programming language is, we've got an API for that. And a lot of great administration control. So we can check all of the boxes and say, yes, Power BI is truly enterprise ready. And if you want to read more, there's a good document for that that's only 260 pages long. And this document gets updated every couple of years. So this is a good place to go. Just a few months ago, Microsoft also created what they call the Power BI Enterprise Hub. And this will be posted on my blog, but you can also go to the Enterprise Hub, where there's a collection of white papers and guidelines around using Power BI in enterprise fashion. Chances are, if you go out and Google how to do something with Power BI, you're going to find the 80% of the community who use it in ad hoc mode, as opposed to the rest of the community who are more enterprise focused. All right, certified and shared data sets I mentioned. So when you have premium capacity, you have the ability to endorse, promote, and certify data sets. This means that once a data model has been deployed to the service, then it can be marked as a number of different levels, but the top of the heap is that it is certified. And what that means is that you can control access differently for certified data sets. when users search for data sets to do their own ad hoc reporting, certified data sets show up first. And it's simply an endorsement that says the organization has certified this as reliable, governed data. All right, how do we future-proof Power BI solutions? Well, it's hard to see what businesses are going to need down the road. BI solutions tend to evolve quickly, and that's why it's been very challenging to kind of apply the same lifecycle management to BI solutions as we have to traditional database solutions in the past, because, as Yoda says, difficult to see, always in motion, the future is, especially in the analytics community. And this is one reason why a lot of data analysts choose to use their own tools themselves. We don't see Tableau, for example, being used in an enterprise mode very often, simply because typically it's on somebody's desktop and that person is a data scientist, or maybe just a really savvy data user, not so much a developer or a database dev. And again, they're mashing up data from all over the place, and it's a very kind of willy-nilly fashion. So what are the reality of BI projects are that you will never, ever, ever, and I'm hoping if you're a database professional that you'll cringe a little bit as I finish this, you will never, ever, ever, ever have all of the requirements defined ahead of time. It's just a reality. It's just the way things are. Well, that doesn't mean we just give up and let everybody do what they want with their data, but it means that we need to realize that these things evolve quickly. I call this the Columbo effect. I work with large consulting clients, large companies, as a consultant, and we'll do our best to get all the requirements ahead of time, and then we'll go dark and close the door and do our modeling and write our measures and start creating our reports. And as soon as you show it to a business stakeholder, they're going to say, yeah, that's just great, but there's just this one more thing that I need. I just need you to add this one more feature. And that conversation will continue and evolve. And it can be a bit maddening as we try to apply some discipline, but it just really, I think, accentuates the need for iterative design. So what does that mean? Well, we define a solution scope. We say, all right, well, this is what we're going to try to accomplish in this iteration. We work in iterative cycles, and at the end of one cycle, we evaluate the design, the thing that we created, against our solution scope, and then we figure out if we've done it right. Keep what works, learn from what doesn't, and throw it away. This is hard for developers, to throw code away, to go build something, to go write a measure, to go Google, how do I write something in DAX? And you go figure it out, and it seems to work pretty well, but then you figure out that there's a better way, or you have somebody do a code review and they offer a suggestion, and that ends up, as a learning experience. Yet we have to be able to part with our code and to part with elements of our design. So discard what doesn't work, learn and improve as we go, and then evaluate to the solution scope so that we're not always wandering into rabbit holes. So how do we manage project files? I'm going to start doing some demos here. So from a database developer's perspective, a database developer is always going to use a source code repository. That might be Azure DevOps, it might be GitHub, but we have a place to put our code, our assets, that is durable, that is versioned, that multiple developers can share. We have a check-in process, and it's completely automated, everything is scripted, etc. So that's the world of the database developer. Now, the world of the business-focused BI solution designer is much, much different. They're typically, by default, going to put things on their desktop. If a hard disk melts down, you're stuck. You lose everything. Now we use cloud storage, and that doesn't happen nearly as often. But again, it's kind of my files in my space. Version control is very manual. We postfix file names. Not a lot of discipline to this, but we can use iterative design, which is simple, and you can deploy directly to the Power BI service from your desktop. Good stuff, very convenient, works for us, right? Well, how do we bring it together? What's the balance? And I would say that the balancing act here is that there needs to be shared storage of some kind. There are very simple ways to share files. Using OneDrive is awesome. You have automatic version control. It's not as disciplined. There isn't as much rigor as there is in an IT environment. If you're working in an IT enterprise project, then we can use GitHub. We can use Azure DevOps, but there are some other challenges there that I'm going to talk about here momentarily. Manual deployment is easy to do in Power BI, and we often don't script data model update deployments and report update deployments, even though it's possible. It's not done very often simply because that's not the way BI projects often work. Now, I've worked on projects where the DevOps manager has kind of put his iron fist down and said, we will automate, and you will provide, you will check in your report files, and you will check in your model files, and then we'll put that into our build process. And because there are APIs and there are endpoints for these things, we can write PowerShell and we can write script to automate, but we don't do it very often. One thing to keep in mind is that you should not ever merge and split a PBIX file. Treat it as a binary file, but I'm going to talk about how to mitigate that and keep it under control. All right, so let me do this. I just want to call out that Power BI model and report files tend to get big as you import a lot of data. And this is a challenge. You can't take a 600 megabyte file, version it every couple of days and check it into GitHub. You just can't do that. You're going to bloat the repository. It's not going to be manageable. It's just not doable. It's also hard to deploy it to the service when you're, approaching a gigabyte file. So that's a problem that we need to deal with, and I'm going to show you how to fix that. All right. So let me do this. I'm going to jump over to my desktop where I have Power BI desktop open. So this is a typical Power BI project. My data source for this project is an Azure SQL database. We'll jump over to Power Query where we can see the actual queries. And I have a slide on this later, so I'm just going to touch on this for now. But every large table, and typically for a dimensional model, typically every fact table, which tend to be the largest tables, I want to make sure that I have a filter to keep the number of records in those tables as small and manageable as possible. So I have a couple of parameters here called range start and range end. Now, I'll just pause a little bit. Those of you who may be aware of the incremental refresh feature within Power BI, that used to be a premium only feature. And these parameters were created specifically to support incremental refresh. Today, it is a pro feature. So you don't have to have premium to use incremental refresh. But whether you plan to use incremental refresh or not, you should use a technique similar to this. And this is what I do on all of my projects. Range start, it's a date time parameter. Range end is a date time parameter. If you go to, I have two fact tables in this model that potentially could have tens of millions of rows. See my online sales table. After I have imported from my sales table, and I've done a little bit of manipulation, notice that I have a filter step here. I'm going to click on the little gear icon, and you're going to see that I'm using those two parameters to filter a date time type column. So here I'm saying I have a column called date partition key. The reason I actually created a custom column is that I have these Kimball style integer date keys. And I had to create a custom column that converted that into a date time type so that I could compare it to two date time parameters. Essentially, I'm saying where my order date is greater than or equal to my range start and is less than or equal to my range end. And I make a point of setting this to a reasonable range of dates. So here I have 1 year worth of data. So 1/1/2020 to 12/31/20. I'm sorry, I'm looking at the wrong ones. Right now I have it opened up for 3 years, but I would typically limit that to a year or less, depending on the data volume. And what that's going to do is it's going to keep the working set of data on my desktop smaller than the entire set of data that I need to offer in my reports. And the reason I do that is because that keeps my PBIX files very small. So if you look at the actual files, this file is only 3.5 megabytes in size. Now, if I were to import all of the available data, let's say 5 years worth of data or 10 years worth of data, that could easily be upwards of a gigabyte in size, which I'm not going to be able to check into a source code repository, and it's going to take a long, long time to deploy every time I need to do an update up into the service. Now, how do I manage these files? Now, typically, I'm just going to put them in OneDrive. Right now, these folders are synced with OneDrive, and if there were a disaster, if my solid state drive on this laptop were to melt down, it's in the cloud. I can always sync that on another machine or sync that back to my drive after I get my laptop fixed. So that's the easy button. I can also go out to the cloud in the browser. I can look at the version history for any of these files, and every time I've saved it, it's creating another version of that file, because behind the scenes, OneDrive for Business is in fact SharePoint, and versioning is turned on. So it's going to keep any number of versions, so I can go back and regress to an older version if I needed to do that. All right, so I've managed the file size, and I'm putting this in a place where I can manage it. I'm working with a large enterprise client right now where my repository for my files is managed in GitHub, and I'm using VS Code to do check-ins every day. And so I actually do have a check-in and a check-out process. All right, any questions at all about Power BI file management or how you can keep the file size down? Since it takes a little bit of time, I'm going to keep going. And Kevin, you are welcome to interrupt me if there are questions on that topic.
Sure, I'll let you know.
Okay. All righty, let me jump back to my slides. I have a habit of kind of jumping ahead with my slides, so we're just about to cover the topic that I touched on. So one of the things that I believe very, very strongly in is that when you are using a traditional data source, a relational database like SQL Server or Oracle or Azure SQL or Synapse Analytics, do not write inline SQL. Don't author your queries within Power Query, within Power BI Desktop. You either want to connect to a view. You saw that I hit my sales table. Or if you need to join some tables together, if you need to do a little bit of data curation in line within a query, then save that as a view. And if you're not the DBA, and if you don't have permission to create and alter objects within your database, then you need to have a good working relationship with the person who can do that. That needs to be part of your plan. There is a feature called query folding that is very, very important to understand in Power BI. When you're working with large tables and working with any sizable volume of data, it's important that queries are executed on the database server, in the cloud, within the engine, whatever that data source is. If it's Databricks, then it needs to be the Spark engine. If it's SQL Server, then it's the SQL Server relational engine. Queries should be executed there. If we write queries in a way that doesn't enable and support query folding, the ability for Power BI to go tell the database server how to execute a query, then what happens is it goes and it streams all of the data down to wherever that query is running, either up in the Power BI service if it's deployed, or on your desktop when you're working in that mode, and that is very, very expensive. So you want to make sure you understand query folding and do what you can to enable it. The easiest way to do that is to make sure that everything is managed in a view. All right. The other thing that I'll point out here is direct query is a great capability within Power BI. Essentially, the ability to reference a source of data without importing it into your data model. It's awesome that we can do that. However, that's also expensive and very limiting. So direct query should not be your first choice. Import by default, use direct query only when required. All right, well, that takes us to where do we transform things? So within the land of Power BI, you really have three different choices. So within Power BI Desktop, we have Power Query. Power Query is an awesome, very efficient, very modern data transformation tool that is baked into Power BI Desktop. Power Query also exists in Excel. So you have access to Power Query in Excel, although an older version. Power Query is available in Azure Data Factory. So Power Query is a tool that Microsoft has baked into a number of their products, but the most modern and most up-to-date version is in Power BI Desktop. So Power Query is a data transformation tool that in many ways is as capable, if not more capable, than SQL Server integration services, than Azure Data Factory. So, you can do a lot of very interesting things. However, you can also use it incorrectly and very inefficiently by using it in creative ways. So when you're thinking about enterprise solutions, think about whether Power Query is the right tool to use. The other option is data flows. Data flows is essentially Power Query in the cloud within the Power BI service. So you can use the web-based tool, browser-based tool, to write your Power Query queries. And those queries are stored up in the cloud in the service. And you have some caching and streaming options that may be attractive. But typically you want to use data flows in lieu of a data warehouse. So if you're building an analytic solution on top of a data warehouse, you already have an enterprise data warehouse, use that. I mentioned using views. Data flows have a lot to offer. Microsoft wants us to use them because they're part of the platform, but it's not always the right answer for everything. So that takes us to the more traditional kind of Kimball style. I'm a big fan of Ralph Kimball and the Kimball Group, even though they're retired. The data warehouse toolkit, I think, as the Bible of data warehouse design, really got it right. Even though there have been more modern approaches since then. Transforming your data before it lands in the data warehouse and organizing data as fact tables and dimension tables will solve a lot of data quality and data conformance problems just by kind of adhering to those rules. So in large projects, we tend to lean toward building a data warehouse first. However, that's not always possible, and a lot of organizations just don't have a data warehouse that supports all of their requirements. So I'll just throw another question out there. Any questions or comments about the balance between using the traditional data warehouse versus these other tools?
We do have a couple of questions. I'll start with the easy one. Will the slides be available afterward?
So I'm happy to share a PDF copy of this deck with you, Kevin. You can share it however you see fit. I have an older version, and we'll post a newer version of this on my blog. And so I have, if you just go to my blog, sqlserverbi.blog, and I have a slide at the end with that link. There's a presentations page, and I keep copies of my presentations there as well. So the answer is yes.
Excellent. The other question, what is the maximum PBIX size that can be published? And is 100 to 600 megabytes, like you mentioned, is that the ideal size for one?
Yeah, I think that's a good rule of thumb. A Power BI Pro license will allow you, from a licensing perspective, to publish a PBIX file size up to 1 gigabyte to the Power BI service. Whether you're licensed to do that or not, a gigabyte PBIX file is big. It's going to be slow. Here in the data bus, we're talking over an LTE cellular connection right now. So we're using Verizon. And I wouldn't think about publishing a file that size over my internet connection. So I'd say that 1 gig is probably a good practical limit. I try to keep my files under 2 megabytes, or under 200 megabytes as a rule of thumb. And using the date range filtering technique that I showed earlier is the best way to do that.
Great. And if we need real-time data and we have normalized tables, should we still transform the tables into facts and dimensions and follow the star schema?
Absolutely, yes. So think about, let's say that we have 2 sets of requirements. One set of requirements says, I want to allow my users to browse this data and get answers to business questions quickly. All right. Well, that begs for a star schema, and it also begs for using import mode, where the data resides in memory, and the Vertipack engine within Power BI can utilize the data model and its relationships. But let's say we also have another set of requirements that says, I have this transactional data, so I want to be able to get to order history and see that data in detail. I want to see every single record. I have tables that are very, very wide with lots of columns, as well as very deep with lots of rows. That's not good data to try to shove into an import data model. So you can build a composite model that has all of your star schema tables in import mode, and then your transactional table or tables that use direct query, and it's possible to drill through to details. I don't have a demonstration within this presentation, but I have demoware, and I've done other presentations where I've shown how to do that. But the key word there is composite. You want to build a composite model where you have the best of both worlds.
That makes sense. Another question from chat is, you mentioned views. What's your opinion on using stored procedures for your data source?
Power BI was not really architected to embrace stored procedures. It's possible. I've done it. Didn't have a real good experience. Power BI likes to select from. It likes to create queries that pass data through queries in the way that we normally select from tables and views, not to execute an object. So, possible, not my recommendation.
Yeah, makes sense. That's about what I've run into in the past.
Yeah, reporting services was the same way. It's kind of the way of the world when you're reporting on data.
Looks like that is all of the questions for the moment.
Okay. All right. So the title of this slide was intended to be disruptive, especially if you come from a relational database background. Kevin, I know that you do. And to tell a DBA or a database professional that the answer to their problem is not to use SQL, it can be a very disruptive kind of thing. And let me just demonstrate very quickly. So let's say that I have a requirement to bring in sales order information by product. Now, the database developer in me says, oh, okay, that's a query that I didn't have Management Studio open, but let me do this. As slow as things are in presentation mode, I'm not going to sit and wait for Management Studio to open. But as I create a query to bring that data in as a database professional, I might think to myself, oh, well, I need to go write a query that joins some tables together. So I already have some parameters here that have my not use a parameter for that. We'll go back and talk to the Contoso DW database directly. Now, here's our option to use import or direct query, and I'm always going to use import unless I have a very, very good reason not to. But I can open this up and I can write a SQL statement. So I could do a, select, column 1, column 2 from orders. I'm not going to execute this. I'm not going to worry about getting it right. Inner join products, P, on, etc. And sure, that's going to give me a result that will bring back, my aggregated sales amount and sales quantity, grouped by product. But in doing that, query folding is not going to work. Essentially, what happens is Power Query looks at this inline SQL and it hands it off to SQL Server and says, I can't optimize this. I can't make any sense out of it. Go execute it, bring every row back, and then we'll apply transformation steps to it after we've imported those 10 million rows. I'm being a little dramatic with the row count, but that's what might happen. However, if I were to not do that, so let's say that instead we do what I've done here, and that is essentially I've connected to my data source. I've then pointed to a view, or I just point to the table and then bring in the dimension table separately and include them in my model. I'm going to have a much better experience. Now, let me show you where there is evidence of query folding working. Why am I not? For whatever reason, I've actually broken query folding here. And that's evident because when I right click on a step and I go down on the menu here, you see view native query is grayed out. That means that I've broken query folding somehow. So let me, what the heck is going on? Maybe it's my parameters. Yeah. So here you can see where Power Query is translating these transformation steps into the native language of my my data source. In this case, it's T-SQL. This was a little surprising to me that query folding is not working after a certain stage. It probably has to do with some changes that I've made to my parameters. So you can see that it's applying transformations. In this case, all it's done is it's just weeded out some of the columns. The query folding is still working. Oh, and it is going to work there. Maybe it just hadn't updated yet. So here's the a filtered rows step. I've chosen a really simple query. All right, so that change type for whatever reason has broken query folding in this case. So that's what you want to do. You want to try to preserve the ability to fold that query back into T-SQL in as many of these transformation steps as possible. Okay, so never forget this. Transform your data as far upstream as possible and as far downstream as necessary. Now, those of you who may be real close to the Power BI community may know that that's a quote from my good friend Matthew Roach, who mentioned that in a blog a few years ago. But I think it's really, really sage advice for any enterprise solution. If you can craft the data and filter it, transform it, shape it upstream as far as possible, then you're going to have a more reliable set of data to work with. All right, object names. Our database developer is going to adhere to using kind of technical names, short names, code-friendly names, sometimes cryptic object names, because DB developers and DBAs are typically serving an audience of developers. So, it's the app developers and the report writers who searching for the word there, who consume our databases, typically not end users who connect to databases. And that's not true within the BI world. In the BI world, we want to make sure that our data models, the queries that create, the measures, the tables, the fields, the hierarchies, that all of those things are friendly and descriptive and make sense to the people who are going to consume those. And that may not necessarily be a technical audience. And so it's okay to have spaces and names. It's okay to use mixed case. And that is not something that database developers are accustomed to. Also, we want to hide columns that are not used by users. So if you're bringing in, let's say, a fact table that has a bunch of foreign keys, there's no reason to expose those foreign keys to users. Just go hide them in the model designer. Users always have the ability to show hidden objects, but by default, we just want to hide stuff that isn't there for a user to drag and drop onto a report. Okay, and second thing to remember is you want to name objects for usability. So referencing Jack Palance there, remember one thing. If there's one takeaway, that is to make your models user-friendly and name objects for usability. Model design. So database developer is typically going to write queries that flatten results. They're going to transform everything in SQL or an ETL tool. They're accustomed to building wide tables that have every possible column, everything that someone might need down the road, pre-aggregate and group the results, and to import summary data. So if we have report requirements that say, I want to see total sales by product, well, we're going to write a query that already groups that data by product, which may remove some flexibility, where a BI solution developer is going to import details, do their transformation in Power Query, and build something that's a little more flexible. Meeting in the middle, the balancing act is to use a dimensional star schema, avoid wide tables, they're poison. 40, 50, 100 column table, absolute poison in a dimensional model. It'll slow things down. It's very unruly and difficult to consume in a report. Remove any fields that you absolutely don't need. You can always go back and add things, but err on the side of removing things that you don't have requirements for. Tall tables are okay. We can deal with millions, even billions of rows, in a well-crafted star schema in your fact tables, but wide tables are absolutely poison. All right, so what does that look like? You look at data modeling options, you really have three categories. You have a flat model. You think about your typical finance business user who uses Excel most of the time. They're accustomed to putting everything in one spreadsheet. That's kind of the world that they live in, is that, if I want, aggregate sales by product, by date, by geography, by business unit, you're going to have a column for every one of those things in a single spreadsheet. Not always the best way to handle a large volume of data. Database developers typically think in terms of master detail. So we've got, order header, then we've got order details. Well, if we take the master detail philosophy, take that model and extend it into dimensional design, it really is kind of master detail all over again. But dimensional modeling is really the answer to a lot of BI problems. So we can think about information in a business sense. What do you want to see on a report? I want to see customer orders by customer, by employee, by carrier, by product, etc. So the intersection between the rows and the columns here represent potentially measures within a dimensional data model. And again, we're just thinking about this in business terms, not technical terms, but as a database developer and a BI power or a model developer, we're going to transform those requirements into a star schema where you have a fact table with the numbers that are aggregated, keys that are related then to dimension tables. And if you're not intimately familiar with the tenets of dimensional modeling, there's some great books, beginning with the Data Warehouse Toolkit, It's an older book, but still very, very truthful. And there's some newer books that are also very good that kind of show modern examples of the same design patterns. So, model design guidelines, dimensional design concepts haven't really changed in 20 or 30 years. That's because they're truthful. It's because data behaves a certain way. And I would point you to the Kimball Group if you just want to get started with understanding the tenets of dimensional design. A great book that I like is the Agile Data Warehouse Development Guide from Lawrence Core, and this is his website, modelstorming.com. Okay, next thing, separating models from reports. So every enterprise Power BI professional will rave about how important it is to separate data models from reports. Power BI naturally keeps everything in one PBIX file. So the file that I was showing you earlier has the queries, it has the data model, which you'll see here in graphical form, and the report pages with visuals all in one place. When I deploy this out to the Power BI service, I'm going to end up with a model file, or I'm sorry, a model object or a data set object, as well as a corresponding report object. So the Power BI service separates them for you. But if you're working in an environment where you're going to have requirements for another report connected to your data model down the road, or you want to separate the data modeling effort from the report development effort and have two people working on that at the same time, it makes a whole lot more sense to have two separate files. Now, there's a fairly simple way that you can start with a single PBIX file and separate it. Now, Microsoft didn't provide tooling for that, but because there are a lot of folks out in the community who support Power BI, a gentleman by the name of Steve Campbell wrote an extension that will split a PBIX file into a report and a model file. Now, I'm not going to demonstrate this because that's essentially what I did to create the files that we see here. So I started with this PBIX file that has the model and the reports all in one file. And I just used the split PBIX option, which just prompts me for this file. And then it wrote that file. That's just the model without the reports, and the report, which just doesn't have a connection to anything. When I open this report file, I can then go change the connection. Let me just show you what that looks like. I'll open that in desktop. Ooh, I just installed Power BI Report Server on my machine, which means that it also installed this older version of Power BI Desktops. Let me go do this way instead. And we'll open it from the file menu. So in this PBIX file, I did not start by importing data. I actually created this by using that split PBIX utility, but I could also just open up Power BI Desktop, go to Get Data, and then point to a deployed data set. And in either of those cases, I'm going to get the same result. This is a very thin, very small file because it has no data in it. And you can see that I only have two icons here rather than this one, because there are no tables. There are only references to tables, so I don't have that little grid icon right there. And if I want to go point this to another data set, then I just go to transform data, data source settings. And at this point, because I'm logged into my Power BI tenant, this is showing me all of the published data sets in all of the workspaces in my tenant. And I just go point to the appropriate data set, and I have a thin report. I can go create as many different reports as I want. Okay. So I have a blog post out there that talks about how to manage separate files. And like I said, there are a lot of community leaders out there who also have similar material. Melissa Coates has a great article on 5 tips for separating Power BI data sets and reports. Okay. All right, managing data set size with parameters. I talked about this earlier, so I showed you the filter rows dialog within Power Query using the range start and range end parameters. To do this right and to follow best practices, I would suggest that you follow the documentation on enabling incremental refresh. Whether you intend to use incremental refresh or not, follow that documentation to create the right parameters with the right data types and to set up these ranges appropriately. And then you have the ability to resize your files whenever you want. And then you can also implement incremental refresh. So let me show you how you do incremental refresh now. So I'm going to close that file, go back to my combined data model. So here within the model, I'm going to go to one of my fact tables. This is a large table where I've used that set of parameters. Click on the ellipsis. I can choose incremental refresh. Now, this is actually a bug in Power BI Desktop that showed up, I believe, a month ago. And I believe it's probably the reason that I didn't see the View Native Query option earlier. So even though my queries are written correctly, it's complaining and saying, we can't verify that M query folding will work. Well, it does because I've designed this correctly. So in order to enable the options in this dialog, essentially what I've done is I flipped this switch. And I said, all right, I want to enable incremental refresh. What I'm saying here is that I want the Power BI service to take over the use of these parameters, and I want it to go build the necessary partitions and manage separate storage partitions for this table. Now, what does that mean? Users will never see it. It just helps us manage data more efficiently within the service. So what this will do, let me tell you what I've told it to do first, and I'll tell you what it does. I've said, I want you to archive 5 years worth of online sales data. And within that span of 5 years, I want to incrementally refresh 12 months. So I want you to break the most recent 12 months of data down into individual monthly partitions. Now, if I had a column in here with a date of last update within this table, I could also tell it to detect data changes. I would point to that column, which I don't have in this table, and it would automatically go figure out if any records within that span of time have changed, and it would process those partitions. So what this actually does, and I'm going to open up Tabular Editor. While I'm waiting for that to open, I'm going to jump over to my workspace. And I'm going to grab the address for this workspace. I've just copied that to the clipboard. I'm still waiting for Tabular Editor to open.
So while that's opening, I got a question in chat. Do you recommend separating a PBIX into data set and report before checking into source control?
Yes, yeah. I would start with separating it. And what that really means is you go author the model. So create your queries. Again, if you're using a relational database, and you'd point to views and import that data, model it, build your measures, do some quick report test pages within that file, and then publish that out to the service. Then open up another instance of Power BI Desktop, point to the published model, and then begin authoring your reports. That's the cleanest way to do it. All right, we're going to point to the address of that workspace, which utilizes the XMLA endpoint. This is a premium feature. And that's going to go connect to the published data set, as it actually sees it as an analysis services database. So there's the database. So there's that data model that I had previously published. So Tabular Editor is now a client for an analysis services tabular database. And that's what a data set is, or a data model in Power BI. It's an analysis services tabular database. What I wanted to show you is that after I have enabled incremental refresh, published my model, and processed it once, that's going to build out partitions. I haven't processed this model yet, so there's only one partition. Let's see if we can do this quickly so you can see multiple partitions. So I'm going to jump over here, and we'll process that model. Oh, and it failed. I am not going to bother debugging this. I don't know why there was an error, but it's not part of my demo that I had practiced, therefore it doesn't work. What we would see is there would be 4 yearly partitions, and each of those partitions would have a date range of, let's see, it's 2022, so 2018, whatever, 5 years ago. January 1, 2017 through through December 31st, 2017. The second partition would be 2018, the third partition 2019, etc. And then there would be 12 additional monthly partitions that would also have date ranges. And so that's what incremental refresh does, is it just takes all that over, it just does it automatically, and it just works. And like I said, incremental refresh is available with a pro license, but you can only manage a model up to 1 gigabyte in size of compressed data. Beyond that, you would need to have either a premium per user license or a premium capacity license. All righty. Okay, use parameters to filter your results. Even if you don't plan to implement incremental refresh, if you use this pattern in a standard way, then you always have the ability to manage the size of your PBIX file so that you can check it in, so that it's small, it's lightweight, you can version it, don't have to worry about using up a lot of space, and then you can implement incremental refresh. Now, even if you don't implement incremental refresh, you can go to the service and change those parameters in the service and just say, okay, well, I only imported 6 months worth of data on my desktop and kept this down to 10 megabytes in size. Now I go up to the service and I change the range so that it's 5 years worth. I process it in the service, and you're good to go. You have all that data available. All right, calculations and measures. Understand the tenets of row and filter context. You want to store detail level calculations. Database developers tend to perform calculations within their SQL because we think in SQL. Power BI and business focused analysts tend to think in DAX. DAX is the calculation expression language of Power BI. If you use it correctly, you don't have to write a lot of complicated DAX unless you're solving really complicated problems. So if you already have a star schema, then most of your measures are probably going to be the sum of some numeric column or the average of some numeric column. And then you may have, some slightly more complex DAX. But generally speaking, you shouldn't have to write really, really complex DAX, unless you're getting into, time intelligence over your fiscal calendar and, a lot of financial measures. All right. And then data security, manage privacy and security according to your data governance policies. It's a fairly simple matter to add users to an Azure Active Directory group and then grant that AAD group access to your workspace app, or individual data sets and reports. So that's the easy button. It's an interop privilege. It's a very simple thing to manage. There are a few different levels of access for both data sets and reports, whether or not you want to allow a user to modify a report, whether or not you want a user to be able to download a file from a workspace, etc. Beyond that, then we have the ability to apply row-level security. And we could get into the weeds and talk about the tenets of row-level security, meaning that a user can only see their stuff. A salesperson can only see customer activity within their geographic region. And that's done typically through using mapping tables, where we say this user gets to see customer A and customer B and customer C, etc. Not a hard thing to implement. Just understand the difference between restricting access to an object, data set or report, and row-level security. Okay, now managing deployments and updates. This is the last topic that I'll cover. So a database developer would typically think about deployment as needing to adhere to rigid development lifecycle stages, meaning we develop in our development sandbox. We deploy against a development instance of our database, then we promote to test or QA. It's tested thoroughly according to a lot of discipline and rigor. And then we have build scripts, and we have rules around when we promote to production, how often we promote to production. All good stuff. It's tidy, it's disciplined, it's predictable. Everybody understands the rules. Within the BI world, we tend to move pretty quickly, and disciplines like this can frustrate the typical BI developer. We want to be flexible. We want to be able to learn as we go. We want to be able to make changes as needed. So how do we balance the two? So the right size process is really going to depend on your audience, the size and scale of your project. As a database professional, as a DBA, as a DevOps manager, I think it's important to understand that BI doesn't always behave like other types of projects that tend to embrace DevOps in a more disciplined fashion. Now, that doesn't mean that we get to break all the rules. We have to apply rigid controls and deal with, certification and data governance and, stakeholder sign off. Those are important things. So we have tools within Power BI that allow us to do that to some degree. Deployment pipelines are a mechanism baked into the Power BI service that allow you to manage the deployment lifecycle of your projects. Now, let me jump over to my tenant again. So I have made a point to create 3 separate workspaces to participate in a deployment pipeline. Now, you can create those workspaces within a pipeline, or you can go create the workspaces first and add them to a pipeline. But here you can see that there are 3 different workspaces that are designated as my development sandbox, a workspace that I, as a developer, will deploy data sets and reports and dashboards to. And once I've done my unit testing and I deploy that, and I test it, I make sure that refresh works, etc., then I can deploy that to test. Okay, so now I'm pushing a copy of this version of my data model, which apparently has changed, and now that's sitting in test. And my QA person has access to this test workspace now. So they're going to go connect to that data set using Analyze in Excel or creating their own report, or maybe I'm deploying reports as well. You can see that those two versions of these assets are currently in sync. They're the same version. Now, there are versioning capabilities here. We can actually go and look at an asset. We can see its versions, and you can roll back a version, etc. Now, we also have a feature called deployment rules. And here we can say that in this data set, I want to be able to add a rule that my database name parameter, say that in my in the copy of my data model that I had developed, I was using an instance of Azure SQL where my database name was Contoso DW-dev. So we could change both the server name as well as the database name. In this case, it's just the database name in the same instance. But we can say that when we deploy to this environment, I want to change that to my production instance or my production database. We could have a dev instance or a dev database and a QA database and a production database, but we'll just have two stages here. And then we have that rule. I've already created that rule. And so when you deploy, it's actually going to redirect. And then when I refresh, it's going to use that other data source. And then we can push that out to production. So this is a very simple thing. It's manual. You have a web interface. We typically just click the buttons to promote these things. And then we can take this production workspace and either allow users directly to access the reports in this workspace, or we can create an app which packages everything up and provides a nice menuing interface for users to come here and be able to browse their reports. So that's kind of the first stage of DevOps for Power BI. Microsoft are working on a set of features which will allow us to fully integrate deployment pipelines and other mechanisms with Azure DevOps. And that's in preview now. It's pretty early in the cycle, but there are a set of REST APIs that will allow you essentially to trigger those deployments, to be able to change settings, to be able to change properties such that I was just showing you in the web interface, and to fold all of that into a DevOps project. And again, I'll just underscore that it's a little early in the preview cycle right now, and this is evolving. But I think you're going to see a lot more about the DevOps integration as we move forward. This has all been in process for the past 3 or 4 years, and finally coming to the masses. Hopefully, it'll be in GA and available for use later this year. All right, let's see. I was back in my slide deck. Let's go back there. All right, so takeaways. Store your source files using shared storage of some kind, depending on the amount of formality and discipline that you need for your projects. It could be something as simple as using Dropbox or OneDrive for Business. Separate the data model from the reports. It takes a little more work when you do that. It means that if you need to go add a measure, you have to go add it to the data model, redeploy it, and then it's available in your report. That takes a little more time. So, in less formal projects, you may want to start without separating the model from the report, and then, mark that separation at some point. You can't go back. So, keep that in mind. I typically will separate as soon as I can. Understand and promote query folding. It's an important concept to understand so that you can build scalable and efficient models that don't import all of the data at once before it's manipulated. Use SQL views rather than inline SQL when you're using a relational database. Use parameters to reduce the working data model size. Consider using incremental refresh when it's necessary, when it makes sense, and then use deployment pipelines to manage the delivery. And again, that's if you have a premium tenant. That is a premium feature. So with that, this was just for reference, kind of left over from another presentation. If you do have additional questions, then I'll entertain those as well. Again, you're welcome to follow both my tech blog, SQLServerBI.blog, as well as our kind of travel on the road blog, dataontheroad.blog. I've interviewed several data community leaders. Had a chance to sit down with folks like Buck Woody and Bob Ward and Adam Saxton to chat about their journey as we've traveled a little bit. You're welcome to reach out to me. I can't promise that I'll answer right away because I do have a day job and do try to enjoy my time away from work as well. If you're interested in learning more about Power BI and being more involved in the community, I would highly recommend that you both follow Guy in a Cube, and on Saturday mornings at 10:30 Eastern Time, we have an hour-long live stream on YouTube, and it's entertaining as well as informative. And if you can spare an hour on a Saturday morning, I'd recommend that you check it out. I'm one of the moderators of the live stream. So with that, Kevin, that's the end of my presentation. If there are additional questions, I'm happy to stick around for a few minutes to answer them. But also thank you for your time.
And thank you, Paul. It's been an outstanding presentation.
Thank you.
So if there are any questions, get them in chat and we'll ask them. But you better type fast.
I've done this presentation about 2 weeks ago. I promised that group that I would publish a copy of this slide deck and my demo files, and have yet to do that. So I promised to get on that. Hopefully I'll have that done tonight on my blog.
Fair enough. What I'm getting in chat, great presentation, awesome presentation. Thank you. And I will once again echo all of those sentiments.
All right. Well, thank you much. And Kevin, thank you for your efforts in leading your local community and being involved in the larger community. I know you've made it out to Portland a few times for our SQL Saturday. And, we've run into each other at SQL Saturdays and the past conferences in the past, and just appreciate all the work that you do.
All right. And with that, we are going to wrap up tonight's session of the Triangle Area SQL Server User Groups Business Intelligence, Data Science Get Together. Everybody have a wonderful evening, and we will see you next time. Until then, take care.